assistant features. And so anytime we use Prism, that's where Clarity is going to help us do our job. So first thing you would typically do when you get a data set from the field is you're going to want to import the data. I do have the import data screen up on the window here. Here on the left, it has all the curves that are found within your source file. The nice thing about this is it's a simple click. If you want to leave out any curves, maybe you have some curves that just really aren't needed, and or maybe you have a very large data set that has hundreds of curves, and you really only need maybe 50 of those. So it can really help you save your data size as you go through this process. Or you can just import everything. It'll automatically do it for you. On the right, you have top and bottom interval. Now, sometimes you'll get data that has null values at the start of the log or maybe at the end of the log. Clarity can actually read those from the data as you import it. So you can filter out the null data by just clicking this button if you wanted to. The rest of the boxes down here, these are generally automatically assigned by Clarity, but it's things like the sample rate, the units, whether it's in feet or meters, how many fingers are in the survey, and radius, temperature, deviation, rotation, things like that. Clarity automatically picks up all of those on the import, but I just wanted to show you the import screen because it's pretty simple, but it's effective. Once you go ahead and select everything you want, click OK, then this background screen, this is what you're going to be greeted with when you import the data. So this is e-centered data, so it's your raw data as logged by the caliper. This is kind of your VDL array sensors over here on the left. It has your finger overlay with the color map. Right here to the right of that screen is your max, min, and mean diameter values as they're logged. Then you have a deviation and rotation panel to see the kind of tool movement as it logged. And then you have line speed and a calculated tool upside. So what I would typically do first is I want to look and see, is the data matching what I expect it to do an early QC process, making sure the tool upside matches the kind of larger recordings you see here on the VDL, make sure those match to make sure that your calibrations look fine. But yeah, this is a good way to do your early QC process. After I'm satisfied with that, typically what I would want to do is go ahead and centralize my data really quick because it's a lot easier to see features in centralized data. So I'm going to run through that process right now really quick, and then I'm going to explain to you what Clarity is actually doing. So I'm going to use this Prism option. I'm going to add a zone, and it's going to automatically select the whole zone. I'm not going to change any of my options there, but I'm going to name my new file. So let's call it centralization. And then I'm going to let it do its thing. So what Prism centralization is doing, this is one of the things where Clarity really helps us out here, is it's taking every cross section and it's looking for outliers, maybe high or low ID features, and it's deciding itself how many of those features to exclude from the centralization algorithm. And if anyone's ever processed caliper data, that's one of the trickiest things to get right if you're doing this manually. Clarity's doing it for me. It's looking sample by sample, and it's deciding itself what to exclude. And hopefully, it saves me some time. I would say I probably use this feature 95% of the time. Joe, I know you've done a lot of centralization. Do you have any thoughts on how kind of Clarity compares to other softwares you use?
That's right. Yeah, just I haven't quite seen as many data sets as you have, but yeah. So I've been using the older legacy software for quite some time as well, and it's a scary proposition sometimes when I must centralize this data. So I'll click on that button, and then I see a window full of some options for me, some parameters that I have to set myself. Perhaps I don't have the most experience when I do this, and perhaps I'm a bit confused by some of the wording that's being used. Things like the outliers, what are outliers? How do I choose the best method? So that's a hugely important step, and it's already asking you questions about how best to centralize your data. And the best thing to take away from that really is is that when you have that experience, you're still compromising on the output because of time. Even if you could successfully centralize the same data set perhaps 10 different ways and then splice it all back together again, you're still not getting that best result at every depth state, every depth step. And that's what Prism offers you, really.
Yeah, I quite like it. It's one of my favorite features because I find centralization can be one of the longest and tedious processes out there to really get right. Because at the end of the day, properly centralized data is what gives you your proper results
Yeah.
In the long run. So we're almost done here. A few more minutes. This is probably the longest process you'll go through because there's probably 1 million data samples in this well, and so it's going through one by one. But in a minute or so, maybe a little bit longer, it's done. So we have a new file written here. We just completed. You can see that data obviously looks different now. This is kind of your standard centralized caliper data. We can look at it full range. Okay, looks pretty good. And so at this point, what I would want to go through is I would want to go through and kind of QC my data. So I'm going to zoom in, went a little far. Let's go back out a little bit. Okay, go back up to the top. Now I can clearly see up here, there's something going on here. We'll look at that in a second. Let's scroll down a little bit. That looks like a completion item. That looks pretty normal. Let's see. Okay, it looks like here we may have an impaired finger, maybe. Okay, that's something we might want to keep an eye on later. And then another completion item. Oh, okay. So we have something going on here at the bottom for sure. Yeah, this is probably why they wanted to run this survey in the first place. Yeah, so we can see by this VDL here that there is some serious damage going on. You can see the high ID readings down here. It also looks like there's some kind of tracks or big patches of deposition here, which you can see in this blue area here and here. But one of the things I'm noticing right off the bat is the centralization. I don't see any artifacts from poorly centered data. Everything looks really well centered. And if anybody's actually tried to center this type of data where you have high and low IDs at the same, kind of cross sections together, adjacent to one another, that can be really tricky. So I would say that Prism really did a good job right off the bat. So that saved me a lot of time for sure. But before we tackle any of this, I talked about the QC process. So what I want to actually do is open up this QC module that's built into Clarity, and it actually is going to assist me. You see the Prism logo there. So what I'm doing is I'm going to search the data, or Clarity is going to do it for me. It's going to search the data for evidence of tool stick and slip. Maybe there was an inconsistent pulling speed, and that can affect the data quality. It's also looking for clog sensors. It's looking for data spikes, any sort of telemetry issues that may affect the data, as well as possible null values in the data. So I'm going to click on run, let it do its thing. And it just takes a few seconds. And then it should give me some results. I like doing this in the beginning because instead of spending time looking, I can just let Clarity do it for me. And it really is a good first line of defense for finding data errors. So yeah, it looks like this is kind of a pass fail results here. Looks like we did find maybe a clog sensor. So I want to click on that and let's go see what we can find. So if I click on this little eyeball, it actually shows me in the data where that is. And you can see here that feature I showed a little bit earlier. Yeah, it looks like that's a clog sensor for sure. But I'm more concerned about these spikes. So let's go look at those next. So if I'm looking for spikes, typically what I want to do is actually look at the cross section that was recorded. So I've opened up the cross section within Clarity, and I'm going to click on the eyeball to look at the first spike. And if I hover over it, yeah, you can definitely see that that's an impossible recording. It's way too large over too short of an interval, so that would qualify as a data spike. That's definitely something I wouldn't want to leave in the data to be processed because that's going to show erroneous values. Yeah, that one even looks worse. And let's check the third one. Yeah, so in a few seconds, I've checked those and I don't like those at all. So I know that this particular customer doesn't want to leave those in. So the nice thing about this QC module is I can actually edit those really quick right off the bat. So I'm going to click this select all, which selects all these options, and it's just for the spikes. I'm going to leave the clog sensors in right now, and I'm going to run this auto edit. So as that's working, it's going to edit those spikes for me. Joe, while we're waiting,
Hmm.
do you have any thoughts on kind of the QC in general from your experience?
Yeah, again, so for anybody perhaps working with legacy software, it's another stage where you think I've been presented with a survey. I've got to start making sense of this, but I've also got to check that I've got some good data. So before you build up that base of knowledge of the however many aspects you've got to check, I've got to check for IDs, I've got to check for data quality issues, is there any deformation? Before you have that base of knowledge, having a start point like this to save you a bit of time rather than to relying on your eyeball as you scroll up and down the data set in that initial stage. I found it to be really useful compared to what I don't think there is really anything available like this in the market just now. For anybody who's
Yeah,
working on a piece of data set, perhaps in a rush, perhaps at 2 a.m, perhaps they've got an interested customer, then just to have this ready to go, that's going to be really useful, I think.
yeah. Well, I would say, I love it because I've been doing this for a long time. I've seen thousands of data sets, but I still like to have the peace of mind that
Mm.
there's some sense checks within the software that'll help me out. Okay, so it looks like we're done here with our filtering, and you can see that where we had the spikes before, those are gone. So that's nice. I would say at this point, I've done just a brief QC with both my eyeballs and with Clarity. I'll probably move on to depth correction, and this is where I've done a little bit of free legwork, I guess. I'm going to open up this completion screen and I'm going to show you what I've already done. And I did this before I got the data set in, which is nice because it can save me a little bit of time. I don't have to do it while I'm trying to process. But if you can see this completion table, we have a few items here listed. We have the top tubing configuration, top and bottom depth and size and weight. We have another tubing configuration down here. It looks like there's a liner section at the bottom. It's the same OD, but a slightly different weight, which is important when you're trying to analyze the data. And then I have a few items assigned to each of these pipe strings. I have 3 mandrels and top of the liner. So in this case, I'm expecting to use those items for depth correction. Depending on the type of customer you have and sort of agreement that they like, you may have more than 3 or 4. You may do a single depth correction point. But I'm going to use Clarity to help me with depth correction next. So I took the time and built this completion table, and I'm going to show you how it's going to help me now. So again, I'm going to use PRISM because I want Clarity to help me with this. And I'm going to go ahead and run PRISM depth correction. So what it's doing is it's searching the data to try to find each of those items within the data set. Particularly what I've already outlined should be there. And again, I got that information from the schematic that I received from the customer ahead of time. In this case, okay, we're done. So now you see that there are 4 entries here at the top. We have our 3 mandrels and the liner top. So let's go see how close we were. Click here, and you can see it pops up on the window. It's not quite where I want it to be for the top of the mandrel, so I'm going to zoom in. And I'm just using keyboard shortcuts, holding control and scrolling with the mouse wheel to zoom in.
Okay.
So it's really kind of intuitive once you learn a few of the keyboard shortcuts. But let's say I call that top of the mandrel. So that one's done. Let's click on mandrel 2. Okay, this one's just slightly high. So let's bring this down. That's the second one done. 3, get it close enough and then I'll zoom in. Okay, let's say I like it there. And then top of liner, let's see. Okay, so looks like clarity was a little bit off on this one, but what I'm going to do is zoom out because I don't think the liner is too far away. Yeah, there we go. So I'm going to put it close, and then I'm going to zoom in, and then I'm going to zoom in a little bit more. So you can see it doesn't take very long, but I like top of liner right there. So yeah, it took all of what, 15, 20, 30 seconds, depending on how quickly you go. And I've already got 4 depth correction points. That could be quite laborsome if you want to do that manually. And then let's call our new file DC for depth correction. And then I always like to save any of the tables that I create because you may find out that you want to reapply those depth corrections or recalibrations or whatever you do at a later point. So I like to save my tables and it stores it for me. And then I can apply and let those changes be made. So yeah, I don't know. What are your experience with depth correction, Joe?
Yes, first up, I'll congratulate you on your good practice there. It's always good to get ahead of the game at the beginning, put the work
Yeah,
in, know what you want to do. You'll have some well information ahead of time. You're going to be able to do some preparation on with the completion window there. Um, in the past, I've also spoken to people who would like to depth correct their data to gamma rays. So that's something that we've got in the wings. We can compare 2 gamma rays to each other and do an automatic depth match to that. So that's waiting to one side in the development plan. So that's
nice.
good to go. Yeah, that's quite easy for a machine learning algorithm to actually to do. So to create those depth pairs that you created in the table there, but also do it automatically,
Yeah.
all the way up and down with a curve like gamma ray. That's coming. Um, I've also there's some. I also remember one guy who wanted the whole thing corrected to colors, each color in the whole survey.
No.
Not sure much we can do about that guy. Having
Well, we've all had
the
that
things.
customer that
Yeah,
wants the world. We can give it to them. It just might take a
might
little
take a bit
longer.
longer. Yeah.
Yeah.
Does anybody
Yeah, if
else
you have
help?
time to build as many of those completion items that I built earlier, then it really didn't take long for Clarity to get us really close and finding those options. And one thing I'll mention is, we do have a machine learning kind of backend engine within Clarity. So the more that we feed the learning process of the AI engine into this, the better it will be at recognizing those features. So yeah, we're done with our depth correction. So yeah, we're well on our way. We've one thing I wanted to note is you see we have these 4 tabs open. So each process that I've done opens a new tab and it saves a new file. But what you can see here is we have this navigation tree on the left, and this is kind of your roadmap to what you've done. So we had the raw data import, we had our centralization. So you can see it's kind of leading into our next step. And then we did our centralization QC, our auto edit here for our spikes. And then we had our depth correction. So it's quite nicely laid out to where everything's, one after another. And you can go through and open these at any point if you want to close what we've already done. So I can clean this up if I want and close everything that we already had open. That might save a little resources going forward on our computing power. Okay, so after depth correction, this is probably another one of the biggest topics. We're going to talk about recalibration next, because recalibration is really looking at errors that we find within the data set that may be actual tool related and not wellbore related. As much as we like to maintain these tools and as good of a job we do, there's things that happen. Things like maybe there's something in the well that's impaired the fingers. Maybe there's slight inaccuracies in the field calibration, which can show up. And let's see if we see any of that here, full range. Yeah, I can quickly pick it out, but if you notice here in this VDL, you have kind of this stripy up and down kind of blue lines that stand out versus the overall pattern. Here's one here that's kind of a high ID. Yeah, Joe, I think, yeah, good job pointing those out. So those are definitely things that, depending on your customer's preference, some customers don't like you to to mess with the tool calibrations at all, and that's perfectly fine. But if you really want to get into the weeds and do some really good cleanup on the data that's really useful, then you can definitely do with recalibration. Another big thing that I'm noticing here, which is kind of odd, is right here in this window right here, I'm seeing a high ID and a low ID and a high ID and a low ID, kind of these four bands. That's typically indicative of ovality within a data set, and that's about 1,500 feet worth of ovality. I don't know that, let's just say that we don't believe that the well is actually oval for 1,500 feet straight. Maybe that's a tool induced error. Sometimes we've seen if the tool is poorly centralized, it can actually, it can deform the oval shape that you would normally record if the tool is better centralized. So in this case, we're going to assume that this is a tool related issue, and we don't really want to report that to the customer. We want to try to do our job as an analyst. That's what they pay us for. We're going to clean this data up a little bit, and we're going to try to process the best data available, right? So this is a good way to show you what Clarity can do, but I'm going to go off script a little bit here. Instead of doing the kind of the PRISM options that we've been doing, I'm going to show you a little bit more advanced topic, and I'm going to do this manually. So I'm going to go over to recalibrate, and I'm going to pull this over to the side. So what I'm going to do is I'm going to break this data into zones, and I'm going to calculate whatever shifts I need to apply to these fingers to correct for the data issues I have. So in this case, it looks like at the top we have a little bit of that alternating high and low ID as well. So I'm going to add a zone at the top. And then what I'm going to do is I'm going to look and see where I think that zone kind of ends. Yeah, so you see it there. So I'm going to say probably around where my cursor is now. It looks like it tries to mellow out right around there, around 3,500 feet. And then I'm going to select my recalibration type. So you can see by the options here, you have three different options. You have an expected known ID, you have a median ID, and a modal ID. So expected known ID, that's going to be useful if, let's say you have a customer that likes you to correct to known IDs in the well. That's really useful to use that if you have completion items with known IDs. Also, sometimes you may have a customer that doesn't have temperature compensated tools and you have a little bit of temperature drift. I would say you're going to see it sooner or later at one point. So that can be used to actually minimize the effects of temperature drift. If you have two features, one at the top and one at the bottom, you can use expected known IDs at each feature, and it will actually straighten out your data quite well and do a good job and still remain accurate. In this case, I'm going to try median ID. And what it's going to do is it's going to calculate a median ID shift value for that particular zone. I'm going to add a second zone now. So here in the middle, I'm going to go from just below the top zone down to probably about this mandrel right here, because that looks like that's all about the same sort of look on the VDL. So let's give it a little bit of a buffer in between. So I'll add an extra 100 feet and then 5,500 feet. Now this is a more advanced topic. I wish I could spend more time with this, but what I wanted to show you is this does have the features to really do a lot of good editing if you spend the time to do it. And then this third zone down here, so let's say right below this mandrel, and then I'm going to go right above the liner top here. So let's go to like 7,200. So 5,600, 7,200, and then let's change this to median. And then let's call this recalibration. And I'm going to calculate my shifts. Now, the nice thing about what Clarity does is it actually, when it applies the shifts, it interpolates between the zones. So you don't see an obvious change in the zones. It really kind of melts together well. And you'll see that here in a second. Again, I'm going to save my zones because I may want to reuse those later. And then I'm going to go through and apply my shifts. So, Joe, as I said, I didn't really use the PRISM way of doing this, but it can do it. You want to
Yeah,
describe that a little bit?
essentially, yeah, describing how Prism would do it would necessitate asking you to describe how you do it manually. So I think we've done it the right way around here today. I think maybe a little bit more of an ask depending on your experience level here. But I think knowing how to do it manually really does just describe how Prism can do it in the background for you. So it's looking for those zones of data to use to create those shift values, and then applying. It'll always apply a median ID, a mode ID, sorry, recal instead of a median ID, um, and it'll correct for the similar features that you see on the screen at the moment. The known ID recal is really quite an interesting one, and knowing the scenarios when to use that, when you might perhaps want to do a comparison over time and you need to reflect the same processing methods over time. That's quite an interesting topic, worth a good sort of half an hour to an hour on its own as well. I think everything we're talking about today is worth an extra half an hour or at least an hour to describe fully. And we're happy to come back and answer any questions later on or even offline as well if there's some topics that take a bit more time to go through. And recal is one of them. So
Yeah, definitely on that note, if anybody has any questions, just plop them in the chat and we'll definitely have a Q&A session at the end. So we'll get to those questions.
thanks, Nicholas. I just got your message there. A shame you can't stick around, but there's a recording, so we'll get back to you on your question there.
Yeah, thanks for coming, Nicholas. All right, so it looks like we're done. So let's see how we did. I'm going to go full range again. Yeah, so right away I can see that the high and low IDs down here definitely have changed. So what I'm going to do is I'm going to click and I'm just going to kind of flip through both so I can see them side by side, and you can see a drastic difference. But what I want you to notice is, yeah, you may be a little bit squeamish about changing the data this much, and I definitely think you should be. It takes some experience, but what I want you to notice is you see all of these individual features. You see these little the blue and the green. This is all actual well features that were there in the raw data, and they're still there. You see, they don't go anywhere. But what we did is we basically took out most, if not all, of the effects that the tool created on the data set that wasn't any fault of the well, really. So we're preserving the data that we need to keep, and we're getting rid of the problems that we don't want to deal with, and we don't want our customer to worry about. That's, like I said, that's what they're paying us for, is for our expertise to know how to handle the data. And really in, less than 30 minutes or so, we already have a centralized data set that is depth corrected to the customer's specifications and has been recalibrated. Really at this point, we're down to probably joint identification next, and that's another big topic, and definitely one that can take some time. So I'm going to delete this table that I already had made earlier. I'm going to show you how to make one from scratch. So I clicked on joint identification here in the top, and so this window pops up here, and you notice the Prism logo. So Clarity can actually assist us with this option as well. So what I'm going to do is just a one button click auto detect, and it's going to find the joints for me. Yeah, Joe, you've done hundreds of data sets yourself. One button click is kind of
Yeah,
nice, isn't it?
it is nice. If there's anything that gets in the way of producing a result quickly, it's trying to find these joints with a set of parameters that you're being asked to provide the software, what sort of
Yeah,
threshold values or cutoffs and that sort of stuff. Just to click one button and get it given to you. Nice.
yeah, yeah. You can see
Login.
we already have a joint table full of joints. So I'm going to widen this a little bit so I have a little bit more room. Yeah, at this point, I would want to go through and see how we did. So what I'm going to do is zoom in. Let's try not to go too far. Let's go out a little bit. There we go. And you can see that each one of these joint connections looks like it's nicely entrenched in these upper and lower boundaries. Yeah, I'm quite happy with that. So you can see it did quite a good job. Now, you'll notice that there's some colors highlighted here. Clarity does a little bit of searching through for you, and it highlights any potential short joints. maybe it added an extra joint where it didn't need to, or you have maybe pup joints or marker joints or things like that that you might want to highlight. So what I can go through and do is double click here, and yeah, it looks like at this completion item, there's a couple short joints. So I'll show you a little bit how easy it is to manipulate this table. In this case, I want to drag this connection down. I want to drag this connection down. I want to drag this connection up, connect this one down. All right, looks like I have an extra joint here. So what I'm going to do is click on it and delete. And then I want to put a name to these. So this joint here, I'm going to call this one. Oh, let me click on it again. Pup joint. And then this is a mandrel. And then pup joint. Yeah, so you can see it adds the annotation there, so it's easy to see on the screen. So yeah, just showing you how easy it is to go through and check out your joints. We'll do one more real quick, and then we'll scroll to the bottom and see. Okay, so in this case, pup joint, mandrel, pup joint. Yeah, so just like that, doesn't take very long before we're nearly done. I'm not going to go through and edit everything. I've already have a joint table already built. So, but that's just kind of a teaser on how Clarity can help really simplify this process. So as we're finished with joint connection or joint identification, really the only thing we're left with is to calculate all of your statistics. So to do that, I'm going to do compute statistics, and this screen will pop up for me. So your kind of normal joint statistics are all listed here. Typically, most customers are going to want all this. This is your maximum penetration, mean wall loss, and things like that. So we're going to leave those selected. We definitely want to include the nominal ID and OD and drift ID of the pipe itself. There's an interesting feature here called PRISM damage classification. So if you and the customer like that, then PRISM or Clarity can go through and actually determine what to call specific damage types based on the recordings. So it has different things it looks for, and we'll go ahead and let it do that and see how it did and see how it does. And in this case, let's call this final file statistics. And then now, if you haven't actually gone through and put in a completion, now is the time you would want to, because if you try to run stats without basic pipe information, it's going to give you an error. So you can click on this edit completion, and then you can add at least the pipe information. That's the only thing you really absolutely need. In this case, I already have it, so we're going to run stats. And while that's running, Joe, why do we even care about this joint identification and completion and all this kind of stuff?
I think it's really down to being able to boil down those millions of data points that you mentioned earlier into something that you can actually talk about at the end of the day. If you want to describe it for yourself, for your own benefits, or for your customers, you really got to find some way of going from all those data points down into joints of casing and tubing or completion items. And then calculating this will let you calculate single values for each joint, so you can then start looking at where my maximum penetrations are grouped, perhaps in different intervals along the well, or perhaps where my restrictions are. That lets you visualize everything into charts and tables, which I think we'll be seeing shortly. It allows you to perhaps, if you're going the whole hog and you're creating a report document for your customers, it really allows you to just start talking and answering questions, as opposed to what we're doing at the moment, which is getting the best data that we can. We're really starting to now basically allow ourselves to answer questions. Why have we run the caliper? We think there's a problem. That's where we're at now. It's really
that's where the expertise comes in.
Yeah. So to have some speed here as well with the joint identification, that's going to help a lot.
Yeah, I agree. Yeah, so we're almost done here. And one thing I like is that it does the work for me, and also at the end I can easily import this stats file into Excel and maybe have a kind of a pre-built reporting template that you can use. That's something I'm going to show here in a second. Um, but before we do that, we looks like we're done here. So you can definitely see right off the bat that our colors have changed here because we now have stats for ID, OD, and pipe drift. Now we have kind of a nice looking display here, something that we can use for reporting. So looks like we have an OD value here from the OD down to the maximum diameter. This kind of visualizes how much pipe remains, your remaining pipe here. And then from your maximum line down to your nominal ID, that kind of visualizes your penetration values. Anything below nominal ID down to your minimum ID, which is your blue line here, that's just visualizing any recordings that are below that nominal ID threshold. And then anything that's below drift value, which I think we had a stuck finger that we left in. Let's go look at that real quick. Yeah, so you can see it here. So that jumps out as this brighter blue. So that's something that either you may want to be aware of because it may affect drift of your well, or it could just be a stuck finger like this. So that's quite nice to visualize the data that way. But another thing I wanted to show you, and something I really like about Clarity is, remember when we were looking at the completion earlier, that we noticed that this was a different pipe weight, and that was based on the schematic that we were given. Um, in some legacy softwares, you can't adequately display multiple pipe sizes on the screen without applying different layouts for each pipe size. With Clarity, you can. And so what I'll show you is, now this is very close to the same size, so it won't be as striking of a difference. But imagine if this was like a 7-inch, maybe something like that, where the scale would no longer work with this color palette. So I can come in here to the settings menu, and I'm sorry I can't go over all these settings with you, but I can show you this really cool feature. We can go into this gradient settings and do an autofill, and that pulls in information from your completion. So it knows where one pipe size starts and one ends, and it builds these color palettes for us. And then click OK, and it'll automatically update our color palette for multiple pipe sizes, which is really nice. So I don't
Nice.
have to change a bunch of things just to report it adequately. Again, the colors won't change too terribly much from what they were, but it's nice to have. That always bothered me about some of the
Yeah,
other software.
right. I was just going to say it's kind of like we're solving some of our own problems that we've encountered over the years by making this software.
Exactly.
What bothers
Exactly.
us probably bothers you as well.
Yeah. So really at this point, we've just processed a data set in less than an hour. That's what it boils down to. Now, as far as reporting goes, you can export all of your stats to Excel. I'll pull up that here. This is a data set that I did earlier. So it has all of your joints listed here and a bunch of different statistics for each joint. You have your annotations here, your pup joints, your mandrels, things like that. But one of the things I wanted to look at, I'm going to zoom in a little bit, is remember we did the PRISM damage classification earlier,
Yeah.
and I was curious to see what Clarity called that sort of damage we saw in the liner section. So it looks like it's listed it as line corrosion, which there was definitely corrosion that was kind of in a line with depth there. Definitely holes and deposition. So it looks like it did a really good job about not only labeling some of the damage we saw, but identifying different damage in the same joint. So more than one type of damage can be in a joint, and that could be useful for a customer. So Yeah, that's quite nice. It looks like ring corrosion too, so that's more of a circumferential corrosion. Yeah, so I think it did a good job, and that can be really useful if you're trying to give context of the damage that's in a customer's well, and instead of trying to do all that yourself for each
Yeah.
joint, that can be
Mhm.
time consuming as well. If you want to take this file and import it into a workbook, like I said earlier, I have one here. This is actually built into Clarity. It's something that we give with the package if you're interested. But you do have the option of kind of creating this sort of workbook type deliverable for a customer if you want to. So this is the same data kind of displayed in a nice table format. It color coded for the maximum penetrations and the maximum wall loss sections, color coded if the IDs drop below drift potentially. So that's a nice thing to give a customer potentially. We have a couple of tables that you can derive from the data. Any sort of damage classification, it can actually add up how many joints fall within a damage classification. So it's kind of a histogram for your different damage configurations. Let's see, another histogram that shows how many joints fall between certain percentages of damage. That can be useful as well to give an overall view of the data. Maybe a minimum ID profile from top to bottom so you can see anywhere you may have an ID restriction. In this case, this was that impaired finger that we decided to leave in, but if this was something more significant, this is really easy to see based on these scales where you might encounter problems drifting. Maybe a maximum penetration overlaid with the wellbore deviation, because wellbore deviation can affect where damage accumulates in the well. So this overlay is quite useful in a lot of times. So yeah, this just kind of a teasers on some of the reporting aspects we have. But on that note, Joe,
Mhm.
are there other things that Clarity has for reporting that can kind of help the new or experienced customer?
Again, yeah, it's a bit of a topic, but if you can imagine you're being asked for perhaps a more of a in-depth report document. You're being asked for screenshots. You're being asked to lay it out with your company's logos and your well information and perhaps your own interpretations. So we'll have to leave that for another time. But if you want to go into our YouTube channel, we've got some videos that cover the custom reporting side of things. So we can actually give you a template that's laid out to your liking, that draws information from the project properties and from the process data and creates screenshots and inserts those charts and tables into a Word document, which you can then take away, perhaps further edit, and then deliver to your customers. So that's pretty quite cool. I'd like to see more people using that. It's a nice tool.
Excellent. Yeah, that's really all I had today. It's like I said, it was pretty quick, and we got through a whole data set that had some issues, and issues that are pretty commonly affecting our data sets that we see day to day.
Thanks very much, Corey.
Yeah,
It's great to have such an experienced brain running us through a data set there. It's really interesting. I'm just going to stop the recording. There we go.